Hello, in this lecture I'm going to talk about different types of data structures that you may find in econometrics. It is very important that you understand the structure of the data before applying any of the tools that you will learn in this class, because the tools that require to analyze time series data, those are different than the tools that you use, for example, in analyzing cross-sectional data. So it's very important that you understand these differences. If you do not understand the structure of the data, you may end up applying wrong tools on a different type of data structure. There are four types of data structures. The first one is called cross-sectional data. The other one is time series. Then there is pooled cross sections, and finally there is panel data. In this class, my emphasis is on the cross-sectional data, as I said in my introductory video. But I will explore a little bit about time series and panel data analysis as well. So in this class, I'm going to explore these three types of data set because these are the most prevalent data sets. And it is very likely that in the future you will be dealing with any of these three types of data sets. I'm going to start with the cross-sectional data because, as I said in my introductory video, it is the easiest type of data to deal with. The whole point is to explore this data, to use this data, to understand some of the mechanisms of econometrics, and then we will apply those mechanisms on some of the other types of data as well. Whenever you look at a data set, you should be very comfortable in knowing that this is a cross-sectional data, or it's a time series data, or it's a panel data. Then you can apply different econometrics methods on that data set. The methods that you will use to analyze cross-sectional data, those are different than the methods that you will use to analyze time series data. So time series data is kind of different. It requires its own tools. So again, it's very important that you understand these data structures. Cross-sectional data, it's very simple. It's a data about multiple entities that you observed at a single point in time. It's a snapshot of a particular data set. For example, you may be interested in knowing stock prices today, and you download the data, you look at the data set. That is a cross-sectional data. You may see stock prices for Google, stock price for Amazon, stock prices for Walmart. See, these are the different entities that you are observing today at a single point in time, and see that you are observing their data for a particular date, which is today, a single point in time. So that is the only commonality between these entities, that you are observing that data set in a single point in time. So cross-sectional data, it's the data of multiple entities observed at a single point in time. If you look at the data, you have to ask two questions. What is N and what is T? N is the number of entities in the data set. If you know that there are multiple entities in the data set, and then you ask yourself, what is T in this data set, which is the time dimension? And if the T is 1, then you know that it is cross-sectional data. Let me show you an example of a cross-sectional data. So this is a cross-sectional data set on wages and other characteristics. And so, as you can see, this data set is observed for 526 individuals. You know that N is 526. So there are multiple entities in this data set. Now, what is the time? Time is 1 because this data set is observed at a single point in time. So you know multiple entities, T is 1. It's a cross-sectional data. So these are the different variables that we are observing. Individual 1, the wage of that individual, the education level of that individual, their experience, whether they are male or female, or whether they are married or not. We'll talk about these binary variable in the future. But essentially, the point is that if you look at a data set and it shows you multiple entities and the data is observed at a single point in time, then it's a cross-sectional data. This is another example of a cross-sectional data. There are 61 countries. See, one country is observed only once. The average GDP growth rate of Argentina is this much. Then there are 61 countries, so there are multiple countries, and every country has only one data point. So all these observations are observed at a particular date. So this is an example of cross-sectional data. The next type of data is called time series data. And if you observe one particular entity and you follow that entity at multiple time periods, then this type of data set is called time series data. For example, if you have data of Google stock prices for the past 6 months, that would be time series data. And in this case, you have to ask yourself, what is N? N in this case is 1, which is Google stock prices, and T is multiple, which is you are observing that data over multiple time periods. So this type of data set is called time series data. I teach another class which deals with time series data. Here is an example. There are 38 observations, but N is equal to 1, because this time series data is on minimum wage, unemployment, and related data of Puerto Rico. So the entity is just 1, Puerto Rico. So N is 1. Time dimension is starting from 1950 to 1987. So there are 38 observations, or 38 time periods. So one entity, multiple time periods. Thus, we know it's a time series data, and these are the variables that we are observing. Okay, so third type of data is called pooled cross-section. So here what you do, there are 2 or more cross-sections. So N is multiple in this case. And what you are doing, you are combining that data set into one data set. An example is, if you want to know the effect of change in property taxes on house prices, what you can do is you can look at the random sample of house prices in 1993, and then you pick another sample in 1995, but you do not follow the same houses in 1995 as you did in 1993. So these are different houses that you are observing in 1995, and then you combine that data set, and the resulting data set that you will get is called pooled cross-section data. So here's an example. So there are 250 observations that you have for 1993, and then you have another 270 observations for 1995, and observe that these houses are not the same as these houses. So these are different houses, and you're observing that data set. You stock that data set together. You're just stocking this data set together and making it a huge, a larger sample. So this type of data set is called pooled cross-section. And finally, the third data type is called panel data. This data set covers not only multiple entities, but also multiple times periods. For example, in this type of data set, you cover multiple entities over multiple time periods. For example, in the case of stock prices, you may be interested in knowing stock price for Google, stock prices for Walmart, stock price for Amazon, prices for Apple in the past 6 months. So see, in this case, you have N equals 5, and here you are observing the same entities over multiple time periods. In the pooled case, you were not observing the same entities over multiple time periods. Those were different entities. But here, in the case of panel, same entities, and you are observing their data set over multiple time periods. And 2 more examples is city crime statistics, and here you observe crime statistics for multiple cities over multiple time periods. And similarly, if you observe house prices in 50 states over the period of time in the last 50 years, that data set will be called panel data set. Here's an example of panel data set. So here you have city 1. So see, it's the same city, and you're observing that city in 1986 and also 1990. City 2, again, 2 observations, one in 86 and the other is 1990, and you have data for 150 countries, and there are total of 300 observations because your time dimension is 2. So here T is 2 and N is 150. This type of data set is called panel data set. I covered 4 types of data sets. The first is cross-sectional data. In that case, you have multiple entities, which means N is multiple and T is 1. The second type of data set is time series data. One entity, N equals 1, and there are multiple T's, time periods. The third type of data is pooled, which means multiple entities but multiple time periods. And then panel is you observe the data for multiple entities over the period of time. So same entities but observing their data over multiple time periods. So these are the 4 major types of data types. And it's very important that you understand the difference between these different data structures, because this will help you to apply different tools that you will learn throughout this course on these different data structures. Okay, So that is about data structures. In the next video, I'm going to talk about causality, the assumption of ceteris paribus, and counterfactuals. All right, see you in the next video.